Hello everyone. Today I am going to discuss one of the most important chapter in physical chemistry, that is electrochemistry. Electrochemistry is the branch of physical chemistry which deals interconversion between chemical energy and electrical energy. Chemical energy and electrical energy. Chemical energy and electrical energy. So we used here a device, particular device. Through the device, chemical energy can be converted into electrical energy, or electrical energy can be converted into chemical energy. It means chemical energy to electrical energy or electrical energy to chemical energy. That particular device name is electrochemical cell. This device name is electrochemical cell. Electrochemical cell. So there are two types of electrochemical cell. One is galvanic cell, another is electrolytic cell. So galvanic cell, one is galvanic cell, another is electrolytic cell. Electrolytic cell. So in case of galvanic cell, this is also a device. It means electrochemical cell. But through the galvanic cell, only we can observe here converted chemical energy to electrical energy. It means this galvanic cell is used for converting chemical energy to electrical energy. Where electrolytic cell, it used for electrical energy to chemical energy. So all of you know the what is the electrical energy. In case of chemical energy, that chemical energy is nothing but that basically bond in between two atom or two element. It means bond related energy, or you can say potential energy also. So in case of galvanic cell, that spontaneous reaction here, spontaneous reaction used. It means those spontaneous reaction release energy, that chemical energy, that release energy converting to electrical energy. But those are non-spontaneous reaction. They are not ready to go participate in chemical reaction. So that time we have to apply from the outside electrical energy. That electrical energy forced to drive the chemical reaction. It means in case of galvanic cell, chemical energy to electrical energy. But in case of electrolytic cell, that electrical energy converting to chemical energy. Now we will discuss about galvanic cell. So before starting galvanic cell, we need to understand some basic fundamentals and tools. That is oxidation reduction. Oxidation and reduction. There are so many theories for oxidation and reduction. With the help of oxidation state or oxygen or hydrogen, an electronegative element. But here we will see on the basis of electron. Basis of electron. So here oxidation means loss of electron. Okay? Loss of electron. Reduction means gain of electron. So oxidation, if we take one example, let's say sodium, release one electron and it becomes Na plus. This is oxidation. In case of reduction, similarly here chlorine, at one electron it becomes Cl minus. This is called reduction. Another term we also use in case of galvanic cell, that is cathode and anode. Cathode and anode. These are both are electrode. Electrode basically used for the surface for electron flow. So cathode, in case of cathode, cathode means always reduction takes place. Reduction takes place. In case of anode, oxidation takes place. Oxidation takes place. So these things, oxidation, reduction, cathode, anode, these are the terms we use in case of galvanic cell. Okay, so let's start with galvanic cell. Okay, another thing that we need to understand. Let's take one example. If I consider here that copper sulfate solution here, copper sulfate solution, it means Cu plus 2 SO4 minus 2. If I dipped here one electrode, that is zinc electrode, clear? What will happen? With time, that electrode here this thing, why? Another thing, that basically color. So this copper sulfate solution, this is blue color. But here with time we can observe here this is colorless. It means we can say here in case of copper, that copper got reduced, and in case of zinc, that zinc element from the electrode got oxidized. So that's why here copper converted as a Cu plus 2 aqueous to Cu solid. So that's why there make a layer, copper layer, and here converted zinc here Zn plus 2. This is exchange copper with zinc. So that's why here colorless, no color. If we do same experiment, here ZnSO4 solution, Zn plus 2 SO4 minus 2 solution, and if I dip here copper electrode, there will be no reaction. Why? There is no reaction. In case of CuSO4, if we dip here as an electrode zinc, we can observe chemical reaction. But in case of ZnSO4, copper as an electrode, there is no reaction. Because here electrode potential. Because of electrode potential. Electrode potential. So what is electrode potential? Electrode potential is basically potential difference developed during the chemical reaction. It means In this solution, CuSO4 solution, if we dip here electrode as a zinc, so in electrode and this electrolytic solution, in between electrode and electrolytic solution, develop a potential difference that is called electrode potential. But there is no development of electrode potential, there is no development potential difference. That's why there is no chemical reaction. But here we can say potential difference develop. So we need to understand the electrode potential through this chemical reaction. So electrode potential may be through the oxidation. That time we can say oxidation electrode potential. If it is because of reduction, that time we can say reduction electrode potential. So that also we'll see in galvanic cell. So galvanic cell based on two half cell. So one half cell here, another half cell here. In left side, we consider a solution that is ZnSO4 solution. Solution of ZnSO4. It means Zn plus 2, SO4 minus 2. Same concentration here also used CuSO4 solution. Cu plus 2, SO4 minus 2. In case of ZnSO4 solution, that Zn plus 2, that ion, that metallic ion. So with respect of Zn plus 2 metallic ion, we used here electrode as a zinc. Here electrode zinc. So here electrode will be copper. Copper electrode. Now, in case of ZnSO4 solution, if I dip zinc and electrode, will be there any potential difference or electrode potential difference will be there? No. Here also there is no electrode potential difference. If we connected these two electrodes through the circuit, what will happen? We can observe electron flow of electron from zinc electrode to copper electrode. This is the observation. Now we have to explain why the electron flow from zinc to copper. As I told, anode, that basically oxidation takes place, cathode reduction takes place. Now we have to consider which one will be cathode and which one will be anode. So there are two electrodes here, zinc, another copper. Now what will be the criteria? Which one will be the cathode and which one will be the anode? There are criteria. We have to check the electrochemical series or reactivity. If we see the reduction potential value of zinc, that is minus 0.77 volt. In case of copper, that is plus 0.34 volt. So here minus 0.77 volt indicates this one highly reactive. It means if we compare copper and zinc, zinc basically easily release electron as compared to copper. So zinc will be more reactive. So definitely zinc will be the, we have to consider zinc anode. Why? Because zinc is highly reactive as compared to copper. That's why oxidation takes place on this electrode. It means zinc metal. So oxidation takes place means from the zinc electrode, zinc release as a Zn plus 2. It means here Zn solid, they release 2 electron and it becomes aqueous. And that releasing 2 electron, each and every element of zinc release 2 electron and got oxidized. So that 2 electron will be the surface of this electrode. So we can say this electrode or anode, because here oxidation takes place. This is oxidation takes place, loss of electron. So oxidation takes place, it means this will be anode. Clear? Here extra electron, it means we can say this is source of electron. Source of electron. Because of extra electron on the surface of this electrode, so that's why here charge will be negative. Negative charge. If you understand this electrode, why this is negative charge, why here we considered as anode, after that we can easily understand this portion. So anode and cathode, which one will be the anode and cathode? That will be the relative things. Here reduction potential value. Reduction potential value says which one will be the anode and which one will be the cathode. These are the relative things. If we consider in case of copper, another electrode that is more positive as compared to copper. So that time we have to consider copper will be anode. This is not fixed. Particularly copper, always it will be cathode. Not like this. Okay. So now lead portion, is it clear? So lead portion, that electrode is the anode and charge of this electrode will be negative. If we understand the left portion, then we can easily understand the right portion also. Zinc considered as a anode, definitely copper will be cathode. Now here what will happen? Cathode means reduction takes place. Cathode means reduction takes place. So what will happen? The flow of electron, that is the observation, from zinc to copper electrode. So it means here copper Cu plus 2 ion, that will got reduced. It means Cu plus 2 absorb, it means gain 2 electrons from the surface of the electrode and it becomes Cu solid. After gain 2 electrons, it becomes Cu solid. That's why here electron deficient. So this will be positive charge. It means here electron, here source of electron. They release the electron. In this electrode, from the solution consume the electron. So that's why electron flow from the zinc to copper. Clear? Now, what will happen after a few moments? Are you thinking the reaction will be continue for a long time? No. Because at the initial time, we consider the same concentration of Zn plus 2 and SO4 minus 2. The concentration of Zn plus 2 and SO4 minus 2 we considered same. In case of copper also, Cu plus 2 and SO4 minus 2. Cu plus 2 and SO4 minus 2. Same concentration. But with time, we observe here from the electrode, the zinc metal, it means here zinc element converted to Zn plus 2. It means with time the concentration of Zn plus 2 increases. In case of right side, the Cu plus 2 from the solution, they converted to Cu solid. It means with time the concentration of Cu plus 2 in the solution reduce. So what will happen? Here the concentration of Zn plus 2 will be greater than SO4 minus 2. But here SO4 minus 2 concentration will be greater than Cu plus 2. Now we can see here this electrode surrounded by only Zn plus 2, Zn plus 2, Zn plus 2, Zn plus 2, Zn plus 2. And this electrode surrounded by only SO4 minus 2, surrounded by negative charge here, and this surrounded by positive charge. So there will be no exchange here. Copper plus 2 to copper, here Zn plus 2 to Zn to Zn plus 2. It means here that charge, highly positive charge here highly negative charge. Now we have to make this highly positive charge here, their highly negative charge, that neutral. To address this problem, we introduce a salt bridge. So what is salt bridge? Salt bridge is inverted U shape. Inverted U shape. Inverted U shape. Inside this salt bridge, normally we used paste or gel type thing, agar or paste, and inert electrolyte. Inert electrolyte. Inert electrolyte. It means inert electrolyte that basically mix with agar or gel type. Then we inserted here. So here inside this gel inert electrolyte are mixed. So what is inert electrolyte? So we have to consider that in electrolyte, those cation or anion will not participate chemical reaction in the anodic compartment or cathodic compartment. So that's why we have to consider inert electrolyte. One thing, when we choose the electrolyte, one should be inert, and another thing that ionic mobility should be same. Ionic mobility should be same. These two things you have to keep in our mind when you choose the electrolyte. One should be inert and ionic mobility should be same of cation part and anionic part, positive part and negative part. Our target, it should be neutral. If we consider two different ionic mobility, one, let's say cation and anion. Cationic part is ionic mobility more as compared to anionic part. So if we paste here, so what will happen? So here higher positive charge. So through this salt bridge, they pass here the negative portion and here positive portion. So what will happen? If we consider different ionic mobility, so the rate of the positive here negative portion will different, here positive will be different. So there will be no electrical neutral. They can't be reached the electrical neutral. That's why ionic mobility should be same. So which KCl, KNO3, KNO3, NaCl, these are basically inert electrolyte. Normally we used. After introducing the inert electrolyte, the reaction will again start. Then again same thing, electron flow from the anode to cathode, and this thing here we can observe light also if we put there, because current is going on, because flow of electron from anode to cathode, flow of electron opposite of the electron. Now with time, the zinc electrode lost their weight also. Why? Because here Zn to Zn plus 2. It means with time that electrode, it means anode thin to thinner. And at the same time here the cathode thick to thicker. It means gain the weight here. Gain the weight like this. When there will be no Cu plus 2 of the solution and there is no zinc of the electrode, that time reaction I can stop. So these are the story of galvanic cell. Now here we have to understand the individual reaction. Anode reaction, cathode reaction, then net reaction. Then we have to learn the representation of galvanic cell. So if we see here, what is the reaction? This is anode. So anode reaction is Zn solid to Zn plus 2 electron. This is anodic reaction or anode reaction. So what about cathode reaction? Cathode reaction, Cu aqueous plus 2 electron, Cu solid. So net reaction will be Zn solid plus Cu plus 2 aqueous to Cu solid Zn plus 2 aqueous. This is the net reaction. Here 2 electrons used, that N is equal to 2. That calculation is very, very important. How many electrons are used in this chemical reaction? So in case of Nernst equation, that time we have to use this number. Clear? Now this is the net reaction. Now representation of cell. Representation of cell means that one trick that we have to always remember, loan. L indicates left side, left oxidation, A anode and negative charge. Clear? So left side always it means oxidation. Oxidation means anode. So here Zn solid, this single vertical line, Zn plus 2 aqueous. This single line indicates the phase changes. So here solid to aqueous. Here double line, this indicates salt bridge. And again Cu plus 2 aqueous, single line, phase changes, Cu solid. So in the salt bridge left side, that oxidation takes place means anode. So this portion indicates anode. So anode oxidation takes place. So Zn to Zn plus 2. It indicates the reaction Zn to Zn plus 2. So right side of the salt bridge, that cathode, Cu plus 2 to Cu, reduction takes place. So this portion cathode. And here reduction takes place. Reduction takes place. So anode reaction here, anode reaction Zn to Zn plus 2 aqueous plus 2 electron. Cathode reaction Cu plus 2 aqueous to Cu solid plus 2 electron here solid. So net reaction here same. So now our main target should be like this. From the representation of cell, we should know how to write the reaction, anode reaction and cathode reaction. If they provided the anode reaction and cathode reaction, from the anode reaction and cathode reaction, we have to write the representation, cell representation, this galvanic cell representation. Clear? So these all about the galvanic cell, individual anode and cathode reaction, net reaction and representation of galvanic cell. So next class we will discuss how to calculate the EMF, electromotive force. It means that potential difference between cathode and anode. So next class we'll discuss. Thank you.